Amen. All right. So, Leonzo or Brandy or anybody else, did you have a specific
The only thing I
question?
was
I was going to
really
go in there.
having trouble with was, let me see, I took a picture of it the day. Um, I think it was the ones with the independent events and the mutual. That I was having trouble with those.
All right.
The mutually
Well,
exclusive.
if you got one in particular, we can look at it. Otherwise, I'll just see if I can get it in the review.
Okay, let's see.
Because the other ones are a little bit harder to get to.
Mm-hmm.
We can look at them. Let's see if I can get it in there. Let me do as a student. Because we got plenty of time. So these would be.
I think that was
See, I
two.
even did one. I
It
even did one late, and see, it came up as 0. So, and that was last week. I don't know why. I guess
Well,
before I
unless you submit it, it doesn't give you a grade.
I submitted
I think
it,
what
and
it
still
is
gave me a 0.
I did it in the teacher's view, and then I never did do it.
See, it still say June 24th. That's why I was
yeah.
saying it.
Well, like I said, is that's the only way I know to do is just go back and
you might need
credit.
to sign out and sign back in.
So yeah, it was in the probability of counting. I mean, rules part 2, and there was a lot of those about the mutually exclusive, the independent. Yeah, I was having a hard time with those.
All right, see, what about this? Let QR be the event that a randomly chosen person has red hair. Let G be the event that the randomly chosen person has green hair. All right, so what we want, and I like to do the using the formula laic way. So it's green eyes, given they have red hair.
Mm-hmm.
That's really all that they want. They don't have any values here. So it's just this. That's all that they want. So we're going to put the G in there. Capital G, I guess. Be better. So that's what they want. Because here's the given. Given that the person has red hair, find the probability that they have green eyes. It's the same kind of thing. So that given that the person lives in Raleigh, so the given always comes after that line. That's your condition. In other words, you're only picking from people who have live in Raleigh. So then that would be the way to put it. We want the probability that they're over 50 years old, given, and that's what that line means. That line means given right there. Okay. So that's 50 years old, given they live in Raleigh. You can write them out in any order, but formulaically, this right here, the condition follows given usually, but they could denote it in some other way. Condition. All right, so let's fill this in. As like I said, I don't know of any way to go through them selectively. So we got a random sample of 125 students and the class they prefer. So click the table. So these all have to add up this way, this way, this way, and then going down. So what I'll just start with is the one that's the easiest, or the just missing one number. So this would be 99. Why would that be 99? Why do you think that's going to be
125 minus 26.
Because 99 and 26 give us 125.
Mm-hmm.
Does that make sense? Here, 66 has to add up with something to be 76. So that's 10, because 76 minus 66 is 10. So 10 is going to go in there. See, 66 and 10 is 76. Now here we can do these going row wise, because we got 2 missing if we do column wise. So we're just going to put a 33 there. Why would we put a 33 there? 66 plus 33 equals the 99. Now we only got one more, so it's 49 minus 33. So 16. All right, any questions about that? Just filling out the misses and numbers in the chart, because they have to total up going crossways or row wise and column wise. Start with the one that's missing the fewest and then work your way out. All right, then they want us to answer the question. So here's the given now. So what we're going to do is we're going to go to morning classes, and we're going to look at that total. Female, given, morning. So then that's going to be at the bottom, the 49. The denominator is 49. And then we look for the intersection between female and morning, which is this one. And I don't believe there's any common factor to that, because this is divisible by 2 and 4. This one is not divisible by anything but 7. So they want 2 decimal places, so we don't have to worry about the fraction. We're just going to take 16, divide by 49. And then we're going out to 2 decimal places. All right, we got to watch this, because this one needs to be rounded. Because out to 3, there's a 6 there, so this is going to be a 3 to be bumped up. All right, questions? What happened to it? All right. All right, so this is a conditional thing. Let C be the event that a randomly selected chosen cancer patient has received chemotherapy. Let E be the event that a randomly chosen cancer patient has received elective surgery. Identify the answer which expresses the following with correct notations. Of all the cancer patients that have received chemotherapy, we're picking out of those, so that's our given now. It doesn't use the word given, but it's setting up the condition first. Out of those, out of the condition patients that received chemotherapy or the given, how many of those had elective surgery? So then this is going to be probability of elective given C. And that appears to be this one, correct? The order on them matters, okay? Because remember, this is conditional. The condition is the second one, the C. And that's the conditional, that line. And is a different matter. It's just and. Okay, so this is written as the probability of A given B, or equivalently of all the times B occurs, the probability that A also occurs. So out of that condition, out of all of the B's, how many have A's? That's all that's saying. Let G be the event that a randomly chosen employee of a restaurant is a general manager. Let S be the event that a randomly chosen employee of a restaurant works at a seafood restaurant. Identify the answer which expresses the following. Given that the port is a general manager, so that's going to be this one, because this is given work at a seafood restaurant that they're also just a general manager. This is given that they are a general manager, which is what they said here, that they work at a seafood restaurant. All right. So I guess I did all these. I don't think there might not have been any like the ones you're asking about in here. Is this the kind you're looking at?
It was
If not, we'll go on to the second one.
Yeah, it was the ones in part 2 about some mutual.
Okay, this right here is an independent. All right. We'll look at this one before we get to 2. All right.
Yeah, it's these. These the ones I was having a problem with.
See, they're independent. They're telling us that. So it's simply the probability so then that's going to be the 2 we're given there, 0.20 times 0. Oh, okay. Wait. This is right, but that's they don't get. I'll show you what I'm talking about. All right. So they're giving us this side. But what we don't know is we don't know the B. So we got to use a little bit of algebra. All right. So in order to solve for that, if you need a little bit more explanation, this it's fine. But that's the coefficient of your variable right here. This is what we're trying to find. So in order to find out what this is equal to, we're just going to divide by that on both sides. So see? And then what is that going to be equal to? So the probability of B is equal to 0.12 divided by 0.1. And essentially that's going back to using that conditional formula. So times 100, so 60%. Y'all okay with that one? Like I said, is when I initially saw it, I thought it was just going to be multiplying 2 values, but they're giving us one, they're giving us the and they're giving us the A, but they're not giving us the B. So then we just replace the and with a 0.12, the A with 0.20, and then to find the B, we divide out the 0.2 on both sides. All right, so we're going to watch this one. This is one of those about mutually exclusive. Pregnant women have an option of being scanned for cystic fibrosis risks in their unborn babies. If a mother or father has a certain recessive gene, the baby is at risk for cystic fibrosis. Given the three events, which of this following statements is true? The mother or father carries the recessive gene. Now, remember, they could count, either one of them can carry it. The father carries the risk. All right. I'm going to do something really funny rather than thinking about it. Let's set it up. Because remember, our formula for OR is like this. And they definitely OR there because event A is OR. And if the part that I'm writing now is 0, then these are mutually exclusive. Well, let's see if we can figure out. Okay, so A and B are naturally going to be overlapping with C, because if either one of the parents, the mother or the father, has a recessive gene, the baby's at risk for cystic fibrosis. So B and C are not, A and C are not mutually exclusive, because if one or the other, mother or father, carries a recessive gene, then the baby could carry it. So those are not mutually exclusive. A and C, the mother or father carries the recessive gene, then the baby is risk. So if either one of those are true, right? If mother or father has this gene. So A and C are not mutually exclusive, but what about one of the other ones, A and B? So B and C is certainly not mutually exclusive, because if the father carries it, then the baby is at risk. But what about this one?
Don't they overlap because the father's involved?
Exclusive. That was the only one.
Yeah.
So the only ones that are mutually exclusive are A and C. They're not, well, that was the only one that was correct. That was the only one that's correct, that the A and C are not mutually exclusive. Because none of these are mutually exclusive, really. They're all dependent on one another. Because if the mother or the father carries the gene, then it's not independent. I mean, then it's not mutually exclusive from event B. And if either A or B is true, then C is not mutually exclusive. So that's what I just explained there, I think. All right, at a certain school, the PTA and the planning board meet at the same time, so a parent can't do both. Find the probability, or if the probability of the parent is on the PTA is 0.17, and the probability of a parent on the planning board is 0.27, what is the probability that a parent participates in the PTA or the planning board? So it looks like we got that same little formula there, but let's break it down and make sure. All right. Okay, so they can't do both. So this is 0. This is, let's say this is the 0.17. And then this is the planning board. So that's -0. So it's not going to affect because they can't do both. So we're just going to add those up. Doesn't say what to put it in, so I'm just going to put it in as it came out because there was nothing to round. So see, it's just using that formula.
So because they can't meet at the same time, that's how you know it's mutually exclusive?
Hold on a second. For some reason you're coming, audio's not coming in.
I'm sorry. I'm on
Talk
my
again,
headphone.
Tori?
Can you hear me?
Yeah, now I must have had mine down and down.
All right.
Okay,
So
go ahead.
because they can't meet at the same time, that's how you know that the mutually
Yeah,
exclusive is
that means
0?
this part is 0.
Okay.
They can't go to both. So in
Okay.
other words, they're mutually exclusive.
Okay.
But we still want to find out the probability of one or the other based upon the individual ones. And all we're going to do is just add them up.
Okay.
All right. If A and B are independent, this is the same kind of thing, except this is for the and this is where we start talking about independence. So if they're independent, okay, so let's just, so we know the and, so I want to put that right here, the 0.54. And then over here, so it's going to be the same kind of thing. We know the A. And then this is the B. And like I said, is you could just put it as an X if it makes it more clear to you, because all you're going to do is just divide now. And essentially, all we're doing is we're using that conditional formula, because the conditional formula and the and are just solve for different variables. So then the probability of B will be 0.54 divided by 0.90. So this is going to be 0.60. Oh, go in there. 0.60. 2 decimal places. All right. Any questions about that one? Like I said, is they do it slightly a little different. They just write it as the formula first, the conditional formula, because we got and we got A. So if we got 2 of them, we can find out what the third one is, the B. All right, this is filling out another one of these. So 155 minus 94. So this would be 61. 109 minus, so that's going to be 62. But 62 and 47 give us the 109. And then now we're going to go this way. I think this is a 31. 32, let me double check it. 94 minus the 62 gives us 32. And then 32 from 46. So 14. So all of these now add up. So 32 and 62 is 94. 14 and 47 is 61. 46 and 109 is 55. And down this way as well. All right, so we're doing another conditional. Here's the given. So we want the senior total to be our denominator. So probability of not vax given they are a senior. So that's NV for not vax. That's this one. So then here is going to be our numerator. And I don't believe we got any simplifying to do. So 2 decimal places, nothing to round. Oh, another one of these. Let's see. So M is marked up and S is a sale. So let's find out what the given is. Given that the store is having a sale, so that's the one that goes there. And the only other thing we have is the markdown. So that's this one here. Okay, so 3 different events. Tom takes the bus to get from the airport to the long-term parking lot. B walks from the airport to the long-term parking lot. So take a bus, walk, and then take a train. All right, let's see what. So there are 3 different ways to commute. Given the following statements, which are true. Well, if he takes the bus, then he's not walking, right? So A and C. So if he takes the bus, he's not taking the train. So that one, whoop, that's not right. A and B are mutually exclusive. B and C are mutually exclusive. So I believe that's the 2. What do y'all think?
I agree.
Yeah, because, oh, there was another one. A and C are mutually exclusive. Isn't that one also? Because they're all, if you walk, then you're not taking the bus. If you take the bus, you're not taking the train. So the only one, all of these were mutually exclusive. All right. At a certain charity, the outreach and financing Financial meetings occur at the same time. So this is that same kind of thing. Impossible for an individual to serve on both boards. So this is that same one, that probably A or B. Minus the probability of both, and they're telling us that they can't do both. So on this one, so it's possible to be and. So this is simply just adding these two up, because this is, we let that be the outreach, and then this be the financial board. So we're just going to add them up, and then this would be 0.92 appears to be. All right, so we're just adding them up because they tell us that they're mutually exclusive. So a couple has two children. Let A be the event that the first child is boy, and note that the probability of a boy is 51.2%. Let B the event that their second child is a girl, with probability be 48.8. So they're independent events. They're telling us what is the probability that has a first child boy and a second. All right. So essentially we're doing and, all right?
So multiplication, right?
Yeah. See,
Okay.
and so probability there's a first is a boy is 0.512. I just brought it back to a decimal. And then the second one is the girl. So it says and, so we're essentially looking for the multiplication of these two. Two decimal places. 2, 5. Okay. Well, we get a number of these things. So this is again, let's find out what they're asking for. M is passes the math test. S, the student studies. The probability that a randomly chosen student studies every day, given, there's the, so it's passes, student passes. So this is the S, student studies. So this is the probability that so it'd be that one, which is the first one. Oh, no, it's the second one, the last one.
Yeah.
Easy to mix up, so. All right, more of these. Thing is, I don't really know how many is left. I'll just do this last one, and then if not, I'll go over to 2. I'm sure probably people got questions about this too. All right, a card is drawn from a 52 card deck. Remember, a deck of cards has 4 suits, each has 13. Given the 3 events, which of the following statements are true? Okay, so drawing a club and drawing a spade, those are those independent? I'm sorry, mutually
Yes,
exclusive?
mutually exclusive, yeah.
Mutually exclusive. But the queen can be both
Yeah.
a queen. I mean, the queen can be both a spade and a club. So A and C are not mutually exclusive because we can have a queen of clubs, right? How about A and B? That's not true because A and B, they are, I'm sorry. A and B clubs, even though they're both black, the black suits, club and spade are different. So those are mutually exclusive. A and C are mutually exclusive. That's not true. B and C are mutually exclusive. That's not true. Because a queen can be a spade or a club. So I think that's it. All right. So this is just add up that one and that one since they're mutually exclusive.
So when they mutually exclusive, you just add them?
Yeah. If they're mutually exclusive, you just add them. If they're not mutually exclusive, then we have to subtract out anything that's common. It's like the union thing. The union of two sets. All right. So here's the two possibilities. Okay. And this is the way I like to look at them as one formula. But if they're mutually exclusive, there's nothing common to them. All right. So we just add them up. But if they're not mutually exclusive, and that's what the little purple area represents there, then we got to subtract that out because that purple is in both A and B. So therefore, to eliminate counting it twice, that's why we subtract it out. And that goes back to that same old formula where we looked at it like this in chapter 2. So that's the same formula. We're just now using it with probability. When we looked over in chapter 2, no overlap. This one's got to overlap. If we got overlap, we got to subtract it out to find both the number in the union or the probability of the or, which is the union. Well, they don't give me a way to skip it, so I'm going to do it real quick. I've done a couple of them, so I'm hoping that y'all got the idea, but if you need some explanation, let me know. So these got to add up. So 86 minus 65, 21. 69 from 74 means 5, I believe. All right, and so this is going to be 26. And then here, we just add those two up, and it should be right. All right, so they're asking another for this. So given they are male, so that's my denominator. So we're going to go to the male, and there's our denominator. So given male, and what was the other thing? Calling as the numerator. We don't need to worry about the fraction because it's a decimal answer. $0.76. Okay, now we're talking about the independence here. So independent events. A is the event that the IQ is greater than 130, and the probability is 16%. B the event that the professional IQ is between 115 and 130, 14%. So we're just going to multiply those because we want one of each. So this is and when they're independent, we just multiply. It's just like the or, we just add. Right, so just add. I'm sorry, just multiply since they're independent. And that's the corollary to the when the two events are mutually exclusive, we just add them up. All right. Let me go over to that other one, the one that people were asking about, because there's still some stuff in there, and if anybody's got it, I'll go. I just want to make sure that I'm hitting the independent stuff. All right. So just asking us about pulling a 7. It has 52 cards. 26 red, 2. So pulling a 7. 4 over 52. 113. It's 4 7s, or 1 out of the 13. They didn't say what to put it in. A musician draws a card out of a standard deck. What is the probability the card is not an ace? So we use the we can use the complement rule. You can do it by just going through and counting all the ones that are not aces. But so this is going to be probability of non-ace is 2/3. 2/13. I'm sorry, 11/13. And again, let me show you this if you have not caught on to this. We're using the complement rule, and if you look at the instructions for the complement rule, often it looks kind of very, very, very complicated because you got to find a common denominator. But if you use this, 1 from 13 gives us 12, not 11. Then that's our new denominator, and we use the same old 13. So Well, but you could have just counted up all of the ones that are not aces, which would have been 12 of them, or 48 over 52. And then when you simplify it, you would get 12 over 13.
Why
Because there's
wouldn't
only
it be
one.
negative? I don't know. Every time I do it, this is where I mess up whenever I'm subtracting the
Well, the probability,
fractions.
remember, probability can never be negative. Now, the
Okay.
full, let me just show you this and see if I can kind of help cut out some of the
Because
confusion here.
I tried to find the well, I mean, I did the common denominator with multiplication. So it would be 113 minus 13 over 13. And that's where I'm getting negative 12 over 13. I don't know if that's dumb.
Okay. So 13 minus 1. So what this ends up being is it means 13 minus 1 over
Okay.
13.
I just had it backwards. Okay.
Yeah. So this is why I say rather than have all that confusion, this is my poor man's complement rule. 1 from 13 gives you 12. And that's your new denominator of your complement. Keep the same denominator, of course.
Okay.
All right. So now we're getting into some independent stuff. So we got this information about students at a university. The probability of the randomly chosen undergraduate attends office hours is 24%. So 0.24. The probability of the randomly chosen undergraduate has a 3.3 GPA or higher is 0.155. I don't think we're doing any multiplication or anything or adding. And so this one is 0.12. Let event A be the undergraduate attending office hours, and event B is an undergraduate having a 3.3 or higher. So those are, they can attend office hours and then get any kind of GPA that they have a gumption to do or the ability to do. Okay, it may be partially dependent upon office hours, but these things can overlap. They can do both. They can have a high GPA and they can attend office hours. And one may affect one the other. Okay, so I think that's true. They are also that's the only answer right there. What about this one? What about this one? We know that this is not right because you can do both, which is why I've selected this one. So this one is not right.
But they
So it's
still
got to be that.
overlap, right? Oh,
Yeah, well, this is the
it's
overlap.
only one answer. Okay.
Hold on a second. Yeah, they're not mutually exclusive. Just double check. And they affect one another. So I think that's all. Yep. So you got to think through all of them. Just don't jump on it. And true by the idea that they were both not independent, not mutually exclusive, means that it rules out the separate ones, individual ones. So 52 cards. All right. A jack. So let's see, how many are there? A diamond, a club, or a spade. Let's look at the little thingamajig, the sample space. All right. So they were a diamond, a club, or a spade. All right. So the diamonds would be that row. The club would be that one, and the spades. And those are mutually, those are independent. Let's see what it is. What is the probability of pulling a diamond, a club, or a spade? Well, 3/4 of the deck is diamond, club, or a spade. So what we would technically do for the formula and they can't happen at the same time, so there's nothing to subtract. So it ends up being 13/50 plus 13/52 plus 13/52, which ends up being 39/52, and both are divisible by 13. 52, 13 goes in 4 times, 39, as you can see, 3 times. So then that is the 3/4. All right, so a college student has 3 pairs of red socks, 4 pairs of green socks, 7 pairs of brown socks in the dryer. So that's 14 pairs of socks total. They reach in to grab a pair of socks without looking. What is the probability they grab a pair of socks that is not green or brown? All right. You think that's saying not green or brown, or is it saying not green or not brown? I think it's saying not brown.
Not both, yeah.
But it doesn't say not both. That's the problem. I think it's saying that it's not green or brown.
Oh,
Not green or brown. Okay, so the probability of brown is equal to 7 over the total of 14, which is 1/2. And then the probability of not G is 10 over 14, because there's 10 that's not green. So 5/7. Well, I'll tell you what, I'm going to leave it as use them as like this, because I think we're going to have to add them together. All right, a college student has, what is the probability? Because it's or. So we're adding them up. Probability of green, brown not green, minus the probability of both if that's possible. All right. So the probability of brown, brown and not green. It might have been an easier way about going this one. This is the first way my mind took off.
But even not brown is 7 out of 14, right?
Yeah, I know. And then that was like, so then it's going to be 3/14. Which doesn't seem right to my, for some reason. Not green or brown. So there's 7 brown.
I don't think they
10
overlap. So I
yeah,
got
I think that's
17 out of 14.
I think you're right. But the problem is, that's not a valid probability then. Oh. So 7. So see, that's not a valid probability if we just add, see, 7 plus 10 over 14 gives us 17 over 14. And that's not a valid probability. So I think that's why we need to subtract out. It might not be right, but we'll worry about it when we come back if it's not. So then that's because see how that one's larger than 1? Not good. And that's a dead giveaway when you're dealing with or probability. It's something that you've not taken into consideration. All right.
Okay, well, 1014 reduces to right? Yeah, to a
Yeah,
half.
5/7.
Oh, 5/7, right.
It's not right. We'll look at it when we come back. All right. Well, let's look at it. Well, I'll put it up here and because it's going to take 2 to get the answer to come up. Okay, well, that is kind of what I did, isn't it? So 11 over 14 is, so this, oh, okay. I see I understand it now. It is not green or brown. It's just not worded very well. Because if a probability of green or brown is 11 over 14, which is what they did, is they got the 7 and the 4, or the green and the brown. So then that gives us the 11 over 14. So that you were right, Tori, that's what that reads as. So let's just kind of fix that.
Okay.
And we'll just know that if we get it, that's what they mean. Not G or B. So then what you got to do is you find the probability of green or brown, which was So this is what they're doing. And I guess it's right. Like I said, I just, it doesn't sound like it's the best worded. And I've run across several problems like that in here. So 1 minus 7 over 4 is the 11. So 11 from 14 gives you 3/14. All right. So we'd have to remember that. All right. Well, I'll see you in a few minutes. Okay.